This video will discuss on the solution to exercise 3.4.1 and 3.4.2. So how to solve this exercise 3.4.1? So when a machine is improperly adjusted, it has probability 0.15 of producing a defective item. Produce defect item. So each day the machine is run until 3 defective items are produced. If this occurs, it is stopped and checked for adjustment. Okay, so means that if we draw this, okay, so we found 3 defect items in these items, okay, and the machine will stop. So what is the probability that an improperly adjusted machine will produce 6 items? Okay, so we may have these 6 items before being stopped. So before being stopped, meaning that they found already 3 defect items. Okay, this stop refers to this until 3 defective items are produced. Okay, so that is our probability. Okay, so we will use this our probability of success, which is getting produced defect item, and then this 6 item would be our number of trials, and our number of success would be 3 defective item. Okay, so number of success would be defined as your R, and number of trials defined as X. So to find X equals to number of trials, 6, in R success, okay, for R success, so it will be, so we define X as our 6, and then your R will be equals to 3, so it will be 6 minus 1, 3 minus 1, your P to the power of R to the power of 6 minus 3, and you will get your answer, which is 0.0207. Now let's discuss the solution. Suppose that a call to a radio station scenario FM gets connected with a probability of 0.05. Assume calls are independent. Okay, for A, what is the probability that the 6th call made is the second call that gets connected? Okay, so our success is getting connected, where the probability of getting connected would be equals to 0.05. Gets connected. Now for A, what is the probability that the 6th call made is the second call that gets connected? So this would be our number of success. Okay, the second call is the success, and the 6th call, meaning that you have tried 6 call, okay, number of trial, okay, to get connected. So number of trial is defined as X, and then number of success is defined as R. Which is 2. Okay, so now we find that X is equals to 6. So we have 6 minus 1, R minus 1, 0.05 to the power of 2, 0.95 to the power of 6 minus 2. And you get the answer, which is 0.0102. And then for B, what is the probability that more than 4 calls have to be made before getting connected? Okay, so meaning that number of trials is that our X is greater than 4. Okay, and before getting connected, so we have to, so number of success would be equals to 1. Okay, so for this case, you have to find x is greater than 4 given your number of success r is equals to 1. So how can we find this? So we are not sure how many calls that is more than 4. So we know that we can find this probability by taking 1 minus the probability of x less than equals to 3. Okay, so to find x less than equals to 3, meaning that we have to find the number of tries when it is 0, and then x equals to 1, x equals to 2, and x equals to 3. Okay, so you need to find one of this, all of this value. So using the formula, we have our x minus 1. So our x cannot start from 0. Okay, so we can omit this because 0 minus 1 here, you will get negative 1, okay, which is wrong. Okay, so we omit this x equals to 0 and we proceed with x equals to 1. So 1 minus 1 and also 1 minus 1 given r is equals to 1 and p is given as 0.05 to the power of 1, 0.95 to the power of 0. Okay, so please be careful. Any value to the power of 0 is not 1, it's not 0. Okay, so please check the value for to the power of 0 and also for this one. Okay, 0, C0. Okay, and then you proceed the calculation up until x equals to 3, and the final answer you get should be 0.8145. Alright, so that's all for this chapter, for this topic. Thank you.